Good morning, students. Mr. Carver here. Today we're going to tackle the final item on the prohibited derivative list, that being quantities other than x raised to a power. And we're going to do that by using the chain rule. All right, so let's go ahead and take a look at this definition here. And you might want to pause it and write this in your notes. When you're ready, hit play. So it says if y is equal to f of u, if that is a differentiable function of u, and u is equal to g of x is a differentiable function of x, then y equals f of g of x is also a differentiable function of x. And the following rule is true. When you derive the composition of f of g of x, and that's again what this is saying right here, this is a command that says derive what follows, what you get then is the derivative of f of g of x multiplied by the derivative of g of x. All right. So what this is saying is, essentially, is that you derive the outermost function first, and then you multiply it by the derivative of the innermost function. So we can go ahead and put that in our notes as well. This is the outermost function. This is the innermost function. And we can carry out this chain of logic regardless of how many functions are embedded in other functions. You can have several of them, as you'll see when we start doing some of these trig derivatives. I know this is a very abstract theory. Let's just go ahead and work through some examples so that you can get an idea of how this is actually implemented. All right, so we'll take a look at this function right here, x squared minus 1, the quantity, all to the third power. And again, this was on the prohibited list because you have a function or a quantity other than just x being raised to a power. Okay, now this is not entirely necessary to see. I just want to point something out here. If I broke this into two separate functions and said that f of x was equal to x cubed and g of x is equal to the inner part, x squared minus 1, I think you might agree then that this expression right there, using these two functional equivalencies, could be written as f of g of x. And if you recall, when you are using functional notation, this says take g of x and put it into f of x wherever you see an x. So if I take x squared minus 1 and I plug it right there, I end up with this function right here. And again, it's not necessary rather to write this out. I just want to point out that when you derive this, what you're going to get then is f prime of g of x multiplied by g prime of x. So let me show you how this works here. F of x is the outermost function. It is something being cubed. So when I derive that, you'll notice here that you don't change g of x. It stays the same. That is the innermost part. So if I was thinking of how to derive something cubed, I think you would agree that you bring the power down to the front, and then I take 1 away from the power. And according to this formula here, my innermost function stays the same, which means in those parentheses, I have x squared minus 1. And now I want to go about deriving the innermost function, this g of x. And g of x is this function right here. So I'm going to multiply that by the innermost function derivative, which is going to be 2x. And that product there is the chain rule derivative of my original function. So again, the notation here is f prime of x. I know it's a little confusing because I'm using f in red here, and I'm also stating that the original function is equal to f of x. But when you're deriving using the chain rule, again, remember you want to work outside in. So let's do another example. And by the way, this would be your answer here, right? That is actually the slope machine of f of x. All right, let's take a look at this one here. And again, this is a quotient. We can actually take that denominator and move it up to the top to get rid of the quotient. But I'm still faced with then the chain rule. So if I rewrite g of x by moving that quotient, or that quantity rather, to the top, that gives me 2x cubed plus 5x plus 1. I'm going to write the square root as the 1/2 power, but I've got to make it negative because I moved it from the bottom to the top. All right. So again, just to point something out, my innermost function is just this portion right here. And my outermost function is something to the negative 1/2. So if you're working outside in, I think you might agree that this operation right there is the outermost operation being performed on this expression here. So that's what I want to derive first. The red underlined part, don't derive it yet until we get there. So if I do g prime of x, I start to derive this. Again, you want to focus on this green portion right here, this negative 1/2. So if it's something to the negative 1/2 power, when I derive that, what I get then is negative 1/2. Remember, I bring the power down to the front, and then I take 1 away from the power. That'll be negative 3/2. And again, according to the chain rule, you don't derive this inner part yet. We'll get to that in just a second, so I want to keep that the same. That's going to be 2x cubed plus 5x plus 1. So now I've derived the outermost function. I'm going to go ahead and cross this out. And now what I want to do is move inside the parentheses and derive that. And again, that's the power rule derivative. So the first one will be 2 times 3. That's 6x squared. Remember, take 1 away from the power. Plus 5x to the 0 power, because this is x to the first, remember. So 1 comes down to the front, then you take 1 away from the power. X to the 0 is just 1. And so I'm done. And by the way, 1 then goes to 0, right? Because it's a constant. And the slope of a constant curve is 0. So this then is the derivative of g of x using the chain rule. Again, by working outside and then in. All right, let's do another one here. All right, now the important thing to remember about the chain rule is that the chain rule problems that you're going to encounter tonight are still going to involve all of the old derivative problems, or derivative rules rather, that you've been learning in section 2.2 and 2.3. Okay, so again, this is a chain rule because I've got a quantity, that horrible fraction inside there, raised to a power, the 3rd degree. So I'm going to focus on the 3 on the outside. I'm going to take care of that thing right first. All right, so if I derive something cubed, when I derive this, I get g prime of x. Something cubed is 3 times that something to the 2nd power. I'm going to cross that off. Now remember, inside, we haven't derived that yet. We're not there yet. We're still working on the 3, so this inside stays the same. That's x cubed over x squared plus 1. And now that I'm done with the 3, I want to go inside and derive this. Well, that's a quotient, so I'm going to use the quotient rule derivative on that. Remember, it is low d high, so I've got x squared plus 1. Remember, I take the low, move it up to the top, and then derive the high. That's 3x squared. Minus then high, which is x cubed, times the derivative of the low, that is 2x. And I want to put that over the square of the below of the denominator. So most of the problems that you're going to be doing tonight, you're not going to be simplifying. We are going to simplify some of them. I'll show you how to do that in another video. This then is the unsimplified version of the derivative of g prime of x. Again, working outside first and then moving inside. All right, just a couple more examples, and I think you guys will be ready to. All right, so if I take a look at h of x here, you'll notice that I have a product rule. So the overall rule will be product rule, and then within the product rule derivative, I may have a power rule, I may have chain rule, whatever it takes to get that product derived. All right, so remember the product rule. I've got h prime of x, and the product rule says derive one of them. So I'm just going to go ahead and derive the first one. By the way, I think I'm going to rewrite this before I start on this. This is x squared times 1 minus x squared to the 1/2 power. All right, so I'm going to do the first one, the x squared portion first. That'll be 2x times the second as is. That is 1 minus x squared to the 1/2 power. And I'm going to add to that, basically, the reverse, right? I keep the first one the same, that's x squared, and then I derive the second part. And the second part, you'll notice here, is a chain rule, because I've got a quantity other than x raised to a power. So I want to focus on this portion right here first. If it's something to the 1/2 power, what I'm going to do is, whoops, I don't want to use red, I'm going to use black. That's going to be 1/2 times that something to the negative 1/2 power. And again, I'm not ready to derive the inside yet, so you got to keep that the same. That'll be 1 minus x squared. Now that I'm done with the 1/2 on the outside, I go inside and take care of that. the derivative of that will be 0 minus 2x. And you want to be sure to include that in parentheses, otherwise it looks like subtraction. You don't want to use subtraction. The chain rule is all about multiplication. Ditto with the product rule, at least that portion of the product rule. So this then is the unsimplified version of the derivative of h of x. All right. Here's a rule I'd like you to get in your notes. Always use the chain rule with trig. And you've actually already been doing it. And let me show you why. If you've got y is equal to the sine of x, and I want to derive that, I get y prime is equal to, if you think about the sine of x or any trig function, you think about this trig portion being the outermost function, and then the x being the innermost function. So you want to focus on the black part first, the outermost. If I derive sine, I get cosine. But I want to leave the x as an x inside because I'm not deriving the x, the inside function first. Remember, you work outside first, then in. So just to keep track of where I'm at, now I'll cross out the sine. And now I go inside and derive the innermost function. I'm going to follow that with the derivative of x, which is just 1. Of course, it's not necessary to write the 1. I just want to point out that you actually have been doing it. You didn't even know you were doing it. So here's an example. Y is equal to the tangent of 3x squared. All right, again, it's trig, so I'm going to use the chain rule. The outermost function here is the tan. So when I derive that, I get y prime is equal to the derivative of the tangent, which is the secant squared. Inside stays the same because we're not there yet. Now I've taken care of the derivative. Now I go inside and derive the innermost function. That will be times 6x to the first. So this is the chain rule derivative of the tan of 3x squared. All right, something quick I need to point out. Remember from trig, if you've got something like y is equal to the sine squared of, let's do 6x to the third versus y is equal to the sine of 6x to the third squared. All right, these are two very different things. Remember that this first one here, when the 2 sits on the trig function, you're really squaring everything. So that is the sine of 6x cubed, that entire thing squared. Whereas the second example here on to the right is y is equal to the sine of 6x cubed squared, and I'm signing all of that. So these create very different answer derivatives, or two very different derivatives rather, when you go ahead and derive them. So let's go ahead and do these one by one, and I think that you'll see the difference. Incidentally, I could rewrite this one on the right. Just get rid of this, make a little room here. I could rewrite the one on the right like this. This is y is equal to the sine of, what is that, 36x to the 6th power. So I think I'll use that one instead. So on the left one here, the outermost function, first is the 2. So when I go ahead and derive this, I get y prime. That is something squared. So I've got 2, something to the first. And again, I haven't gotten to the inside yet, so that stays the same. All that to the first. Now I'm done with the 2. And now I go inside here. And what you'll notice here is the sine is the next thing. That's the next outermost function as I work inside. So that'll be the cosine. But I'm not to the 6x cubed yet, so I just write that down. That's the sine of something that derives to the cosine of something. Now I'm done with that. And now I want to go inside and derive the innermost function. That'll be 18x to the 2nd power. All right, now this one, the outermost function, in this case, is the sine. So when I do y prime, it's the sine of something. That goes to the cosine of that something. Now I'm done with the sine. I go inside and derive 36x to the 6th. And that gives me 216x to the 5th, right? The 6 comes down to the front, multiplies by the 36, take 1 away from the power. So you can see you get wildly different derivatives depending on how it's written. So please pay attention to how it's written, and then maybe you take the time to rewrite it like this so you can clearly see what is the outermost function, the next outermost, etc. All right, one other thing about trig, let me just point something out here. Let's say I've got y is equal to the cosecant, the square root of 3x cubed plus 1. All right, so I'm going to rewrite this. This is y is equal to the cosecant of 3x cubed plus 1, all that to the 1/2 power. And I want to also group this together because I'm cosecanting, if that's actually a word, that entire quantity. And that helps me see that the cosecant is actually the outermost function. So when I go to derive this, I've got y is equal to the derivative of the cosecant of something. And if you recall, because you have these memorized, the cosecant derives to negative cosecant of that thing. That's 3x cubed plus 1 to the 1/2 times the cotangent of all of that, 3x cubed plus 1 to the 1/2. So now that is the derivative of the cosecant, right? Cosecant goes to negative cosecant cotangent, and each of these get that original quantity of 3x cubed plus 1 to the 1/2. So now again, now I'm done with the cosecant. Now I go inside here. What I notice here is that the 1/2 is the next outermost function. So if I drive something to the 1/2, that goes to 1/2, 3, that something, don't derive that yet, to the negative 1/2. Now I'm done with the 1/2, and now I'm left with the derivative of the innermost function, which is that right there. So I'll follow that up with 9x squared. And again, all this stuff is being multiplied together. And that is the highly horrible derivative of my original y. Now, I've got a second video that I'd like you to take a look at, and that is how to simplify these derivatives. No calculus involved in that. It's just pre-calculus and algebra 2, but it'll walk you through some of the algebra just in case you've forgotten things like complex fractions, adding fractions, common denominators, all that great stuff. All right, guys, I will see you soon. Best of luck with this. Thanks.